Hello everyone, how are you all? I hope you all are fine by grace of God. I'm also fine here. I'm here to explain to you today the derivation of the equations of motion. In the chapter of motion in a straight line, this is quite an important topic for you to practice and write in the examination. So here they are. The equations of motion, as you have already seen, are V equal to U plus AT. The second one is S equal to UT plus half AT square. V square equal to U square plus 2AS is the third one. So the symbols which have been used in these equations of motion are V equal to the final velocity and U the initial velocity, A the constant acceleration, T is the time period for acceleration, and S is displacement. As this chapter is motion in one dimension or motion in a straight line, keep it in mind, all we are concerned with is displacement which the body is traveling in time t. It is not the same as distance because that is simply a scalar quantity because and there is no specification of direction along with the body is moving. Okay, so the body simply may move in a zigzag path, the body simply may move in a curved path. So in distance we are concerned with the length of the path which the body is traveling. Okay, and in displacement we are concerned with the straight line path, the distance of the straight line path between the initial and the final point. Okay, so this is displacement and this is constant acceleration. Important point to be noted is that these equations of motion are only valid with constant acceleration. As soon as the acceleration is changing, these equations of motion are no longer going to be applicable. So these equations of motion will be violated. So these are exclusively used for constant acceleration. So the case is like this: a body had initial velocity which is u, and a force was applied on the body, as a result of which it gained an acceleration and it started to move with a constant acceleration a, and after time t the velocity changed from u to v. V is definitely greater than u. The time interval for which the body has moved with constant acceleration is t. The length of the path which the body has traveled along a particular direction is s. So this is basically s from here up to here. S is displacement. Okay, the displacement. So s is displacement here. Now let's see how the equations of motion can be derived. By definition of acceleration, we know acceleration is the rate of change of velocity with time, or rather more specifically the rate of increase of velocity with time. And the velocity is here is clearly increasing because the body has been acted upon by an accelerating force. It has gained an acceleration and started moving with the acceleration for time t, after which the velocity has increased to v from u. So by definition, A equal to v minus u by t, because A is delta v by delta t. Change in velocity by change in time. By definition, what acceleration is? Change in velocity by change in time. So how much is the change in velocity? Final velocity v, which is greater than the initial velocity, which is u. So change in velocity v minus u. Alright, and this course of time for which the body has moved with acceleration is t. Time interval I told you already earlier. So now after cross multiplication, AT equal to v minus u. So take this u to this side, you are getting v equal to u plus AT. That is your first equation of motion, the easiest one of the lot, the basic one. final velocity equal to initial velocity plus acceleration multiplied by time. So now you try to understand the body is moving under acceleration. The velocity of the body is variable. It had a certain amount of initial velocity. After that it was acted upon by the force and it gained an acceleration. With the acceleration it is moving for time t. After time t the velocity has changed to v from u. Okay, so actually for this span of time t the velocity is variable, isn't it? Because the velocity is constantly increasing, because the question of acceleration automatically arises as soon as the velocity is ever changing. The velocity is constantly increasing, gradually increasing velocity is the one with which the body is moving. So in case of variable velocity, all we are concerned with is average velocity. We can get a concept of the velocity of the body with the help of the average velocity if the velocity is not constant or uniform. So here we need to find out the average velocity of the body if we want to get an idea of the velocity. Average velocity is nothing but the average of the initial and the final velocity. The initial velocity was u, the final velocity was v, so average velocity is supposed to be u plus v divided by 2. Alright, so here this s or displacement is distance traveled along a straight line, because in this chapter we are concerned with motion in one dimension or motion in a straight line. So along this straight line path the body is traveling a distance which is s, displacement. Equal to average velocity multiplied by time. As you simply know the formula in terms of time and distance, that is distance equal to speed multiplied by time. So here the corresponding formula for vectors is this: displacement equal to average velocity multiplied by time. Average velocity into time. Okay, u plus v by 2 into t. So now all we have to do in this very step is substituting this value of v over here, because in the earlier equation we have already ended up getting this equation v equal to u plus at. So in place of v, is it okay to write u plus at? Yes, it is okay. So in place of v you write u plus at. U plus at divided by 2 into the time. So 2u plus at by 2 into time is equal to 2u by 2, how much? Is u. At by 2 is half at multiplied by the time. So finally we have ended up getting the equation is equal to ut plus half at square, isn't it? So this is your second equation of motion, which is giving you the value of displacement that the body has traveled in time t with constant acceleration and an initial velocity u. Okay, after this come to prove the third equation of motion. I'm writing here the second equation of motion we got to prove right now, because this is an expression which we shall use in proving the third equation of motion. These two are proven already, third one we are going to prove now. So right from the first equation of motion which we proved in the beginning, we need to square both sides. Squaring both sides we can get v square equal to u plus at whole square squaring both sides. V b square equal to, now apply the expansion for a plus b whole square. What was it? A square plus 2ab plus b square. Is it okay? Now from these two terms take out the common factor 2a. 2a, if we take out 2a as common, then all that is remaining from this term is ut, and the part remaining from this term is half a t square, isn't it? Because you multiply them together. 2a multiplied by this one ut is 2uat, right? And then 2a multiplied by half at square, 2 and half are cancelled out. All that is here is a into at square, means a square t square. I hope this was clear. And now you tell me how much is this ut plus half at square. Have a look at the second equation of motion we derived a few minutes ago. A is equal to ut plus half at square. So well, we can substitute in place of this, the part within the bracket is s, isn't it? So write that v square equal to u square plus 2as. Okay, and we have reached the form of, for the third equation of motion, v square equal to u square plus 2as. That is the way we can prove easily the other three equations of motion, which are exclusively valid for constant acceleration. Keep it in mind, an important point to be noted. Okay, as long as the acceleration is constant, so long these equations are going to be applicable and hold true. As soon as the acceleration starts changing, these equations will be of no use. These equations will no longer be valid and applicable. These are the equations of motion for a body which is moving with constant acceleration for time t. The body had started its motion from initial velocity, which is u, and has moved with constant acceleration for time t. The displacement which the body has traveled is s. Final velocity the body had acquired after time t is v. Okay. So that's all, students. That's all I had tried to explain you. I hope you could follow it clearly while I have tried to explain. In case you still have some doubts, feel free to let me know in the comment sections. Also let me know the topics in which you want me to make videos. And that's all. Take care. Bye bye.